All right, so in chapter 6, we're going to talk about the relationship between returns and risk, or risk and returns. And this is not a particularly, this is a setup chapter is what it is. We're going to talk about the capital asset, capital asset pricing model next week. And when we do that, before we do that, we need to talk about what risk and returns look like. So the first thing we're going to talk about is this tiny little graph that's going to measure risk, and over here it's going to measure returns. So there exists this line, I'll do it in orange, that has a positive slope. That might be a little dramatic, but it has a positive slope. And on this line, we can put in our big asset types. And down here, where there is low risk, we're going to put in bonds. And up here, where there is high risk, we put in stocks, high risk. And so under here, we have all sorts of different types of other assets that come into play. And what we're trying to do is just talk about the relationship between this risk and these returns. Let me find even another color or something a little brighter. And over here, the safest, lowest risk we can possibly get that we put basically at zero risk are treasury bills. And then over here, we're going to put treasury bonds. And you can see how these start to get a little bit riskier over time. Here we put municipal bonds or corporate bonds, and they continue to get riskier and riskier. Over here, we're going to put preferred stock, and then finally common stock. And we can go way out here and do stuff like derivatives because they're super high risk, but we can talk about those later. Okay. Clearly there's a division here between bonds and stocks in the two asset class types. And the higher we go, or the further we come to the right, as the higher we increase our risk, you can see that there's a positive relationship, which also says that we should get higher returns. We can describe this as expected returns, or the returns that we expect to get given a higher investment risk. What's important here is that this orange line, not only does it exist, but we walk on it, this orange line, we walk up and down this risk line depending on what it is that we think we should be investing in. All right, so the first question is, how do we measure returns? Well, measuring returns are easy. Returns are equal to the final value of your investment minus the initial value of your investment divided by the initial value of your investment. Okay, it's as simple as that. So let's pretend for a second that you invested $100 into a baseball card, and you then drove across country where they have never heard of baseball cards or whatever, and you sold this for $150. What is your return? Okay, you bought it at 100, you sold it 150, and you think to yourself, well, my return is $50. And that's correct. Your actual return, or your capital gain, or your dollar return is 50 bucks. But what is your percent return? Well, it's 50 bucks. I mean 50%. Well, how do you know it's 50%? Well, it's real simple. And in your mind, when I asked that question, you very intuitively just did this same calculation. What is the final value? The final value is 150. This is the value at which I sold the card. What is my initial value? That is the value at which I bought the card, and I'm going to divide it by 100, and that gives me 50 over 100. I'm a little slanted here, and that equals to 50%. Ta-da! So nothing really fancy there. That's how we measure returns. One minus the other divided by the original, or I should say last minus first. Final minus initial divided by initial. You may also see this in terms of time periods. So you'll see time period 1, or value at time period 1 minus value at time period 2 divided, or time period 0 divided by the value of time period. So you might see something like this. It's the exact same thing. All right. No big whoop, no big confusion. That's not a problem. The next question is, how do we measure risk? And this, I'm going to spend a completely separate, uh, I'll do this in a completely separate micro lecture. But for the time being, let's do another practice problem for expected return. But let me continue on expected return. We'll do a quick practice problems and I'll continue. So let's say that um, you purchased your car at $10,000 and you drove it for a couple of years and you ended up selling it for $8,000. Well, what does this equate to? What does this equate into? This equates into the final value was 8,000. So let me write it up here. Final value minus initial value divided by initial value. 8,000 minus 10,000 divided by 10,000. And this makes sense because we've lost value on the car. We're just trying to figure out how much, okay? So this is going to be 2,000 divided by 10,000, which means that we have -2, actually, -2,000, which means that we have -20% return. We actually lost money on the deal. And that's to be expected because it's a car and cars go down in value over time. That should be it.